Hello everyone, I'm Elias. For today's lesson, uh, I will show you simplest steps that you can follow on solving or finding a basic visible solution of a transportation problem by using a least cost method. As you can see here, we have one example here. Find a basic visible solution by using a least cost method. So we have data here. We have our data here. As you can see here, we have demand 1, demand 2, demand 3, demand 4. We have supply here, supply 1, suppliers, supply 2, supply 3, and for supply 1 this 7, supply 2 9, supply 3 is equal to this one. So and the first demand is 5, second one is 8, third one is 7, and the first one is 14. So I'm going to show you step by step on how you can find a basic visible solution by using least cost method. How you can minimize this transportation problem by using least cost method. As you can see here, you can draw a list of rows and columns, as you can see here, and copy this data here like this. You have 19, 17, and so on. So after doing that, then you can draw a small square like this one at the middle, this one, or like this, as you see here, as you can see here. From now on, by using a least cost method, what you are going to do here is looking the smallest number at this area here. The smallest number here at this area here, and then we start operating from that number. As you can see here, we have 8 here. This is the smallest number as compared with these other numbers. So we start working from 8 here. So before we start working, something to remember, you must consider this demand. All of these demands must be equal to sum of all supplies. So as you can see here, if we sum 8, 7, 8, we sum 5, 8, 7, and 14 equals to 34 here. And even if we sum 7 and 9 and 18 here, you will get 34. If it's not balanced, you add something, we add a column here, and you add something we call it dummy or dummy supply, and dummy or dummy demand here, and supply here you add here. But for our question here, it is balanced. We don't need to add anything here. Then as we have determined before, we said that our list number is 8 here. So we start working and the 8 here. So as you can see here, our demand here is 8, and our supply here is what? Is 18. So since our demand is 8 and our supply here is 18, then we can supply here 8 after supplying 8 here, then here now we can minimize, or we can subtract 8, then it becomes 0 here. Here we subtract 8, it remains will remain with 10 here. As you can see here, the following list cost is this one. This is the following list cost is 10. So as you can see here, our demand here is 14. Our demand here is 14. As you can see here, our demand is 14 here. Our demand is 14, and our supply here is 7 here. Our supply is 7 here. So we add 7, we put 7 here, and we subtract 7 here from our demand. We remain with 7 here, but here we have 7 we have supplied here, then we cancel out 7 here, we remain with 0 here. As you see now, after 10 here, the following list cost is this one. The following list cost is this one. So the following list cost is 19. So as you can see here, our demand here is 5, and our supply here is remains 0. So we cannot supply 0, then it will remain 0 here. As you can see here, after this we have 20 as a list cost here, and you can see our demand is 7 and our supply here is 10. So it will supply 7 here, we subtract 7 here to remain 0, and we subtract 7 here, it will remain 7 minus 10 minus 7, it becomes 3 here. The following list cost then is 30. This one, this 30 here. But our demand here is 0, so we cannot supply anything since the demand is 0 here, so we put 0 here. Also, you can see here, the following list is 30. Then also we have 0 here, our demand is 0, and our supply here is 9, but we cannot supply since our the demand is 0 here, so we'll put 0 here. Then the following list cost is 40. We have 40 here. We have 40 here. As you can see here, we have our demand is 5 and our supply is 3, so we cannot supply more than 3. So we supply 3 here, then we subtract 3 here, it becomes 0. Then here we subtract 3, it becomes 2. Then the following list cost is 40 here. As you can see, we have our demand is 7 here and our supply is what? 9. So we can supply 7 here, minus 7 here becomes 0, minus 7 here becomes 2. As you can see here, then the following list cost is this one, 50. So 50 here, as you see, our demand is 0. So since our demand is 0, we put 0 here. Then the following list cost is this one, 60 here. Our demand is 0, so we cannot supply anything. We can't supply, then we have 0 here. Then the following list cost from 60 is this 70. As you can see here, 70, but our demand is 0 here, so we put 0 here. Then the following is this one, 70. You can see, as you can see here, our demand is 2 and even our supply is 2. So you can put 2 here, and 2, then 2 minus 2 equal to 0, then 2 minus 2 equal to 0. As you can see here, our demand and supply has balanced. As you see, as you can check here, there is only zeros, and here there is only zeros. So the minimum cost from the table above, minimum cost equals to, you multiply this value, this time this time this time this time this. So as you can see here at the first row here, all of this becomes 0. So our as you multiply this all of this becomes 0. Then we come up to here, we'll have 10 times 7 plus this here equal to 7 times 2 plus this 0, this equal to 40 times 7, then plus this becomes a 0, this and this equals to 40 times 3 plus this and this equals to 8 times 8, then plus this and this becomes 0, then it becomes this and this. We have 2 times 7. So when you multiply this and add, you'll arrive into 814. So this is the minimum cost. So this is the minimum cost. These are now how you can find a basic visible solution of a transportation problem by using a least cost method. Now this is the final answer. Thank you.